This is an interesting slide to look at for a variety of reasons. It's actually a slide of a developing animal paw, and so what we have in this region here are the developing wrist bones. This is actually the radius here. Here, up along here, and we'll see it in more detail, is one of the metacarpal bones. Here's a part of another. And then we have the distal phalanges developing up in this region up here. The surface of the paw is lined with skin, stratified squamous keratinized epithelium, which has hair. So you can revise that epithelium by looking at the surface of the skin here, and these structures out here are claws. You need not pay too much attention to those. Where we're actually going to look is at the wrist bones or carpal bones here, and at this metacarpal bone. And the reason for that is as follows. You'll have read in the notes that all of the or many of the bones in the body develop from a hyaline cartilage model, and here what we're looking at are the hyaline cartilage models of the wrist bones, and at this point over here a hyaline cartilage model of the, or part of the radius. And the reason that I really wanted to look here was to show you two features of hyaline cartilage. One is the general appearance of developing hyaline cartilage itself, which is here and here. So here what we see are cells in their lacunae, surrounded by a little territorial matrix, although it's not as obvious here. And the tissue itself is quite cellular during the course of development, with this nice homogeneous hyaline cartilage in the background. The key feature to see here is this accumulation of cells which we see just at the surface here, and this accumulation which we see just at the surface here. The bulk of the cells arise by mitosis at these surfaces, so this is essentially appositional growth, and then cartilage is secreted maximally by cells further in from the surface, and this is where interstitial growth occurs. The gap which we see here is where a synovial joint will develop between these two bones. And the key feature to note here is that where two bones, and remember these are cartilage models that will be replaced by bone, where two bones abut one another like this, they have on their surfaces a layer of articular hyaline cartilage, and articular hyaline cartilage is distinguished by the fact that there's no dense irregular connective tissue perichondrium surrounding this part of the hyaline cartilage. If we go back out in magnification, and if I move here across here, now we're going to look at one of the metacarpal bones. It's a classic long bone in its appearance. Here's the head on one side, here's the shaft, and here's the head on the other side. And this is early enough in development that the head is still a cartilage model, although there's a developing epiphysial plate, and some bone has developed down along the walls of the shaft here and down along here, and there's bone marrow present in the marrow cavity. So first let's look at the head or epiphysis on this side, on the wrist side, and as we go up in magnification, hopefully you'll already have studied the epiphysial plate video, and you should be able to recognize a resting zone, proliferative zone, zone of hypertrophy and cell death. Here just at the edge of the epiphysial plate, very nicely demonstrated, are mixed spicules. So the purple core here is calcified cartilage, and the bright red material which is being secreted onto the surface by the cells, you can see the nuclei of them here. These are osteoblasts secreting bone onto the surface, and this is a classic mixed spicule, a little spicule of material that's made of a calcified cartilage core with newly laid down bone on the surface. There's a blood vessel just here, and these blood vessels bring in additional cells which will convert into bone cells. So a nice example there of mixed spicule. Now as we move down here in the center of the shaft, now we'll see here is where there's bone marrow, and really what we want to look at here is just along here the cortical bone which is developing on the shaft. Now this bone has been laid down, it's been converted from a cartilage model, but it's not yet been fully remodeled to form lamellar bone. And what I wanted to see at this point here is to see these bone lining cells here which line the outer surface, and then detaching off the surface here this bit of dense irregular connective tissue. This forms the periosteum of the bone. and not as evident on the inner surface, although occasionally we do see some cells like this. There's a very thin layer of endosteum, connective tissue, lining the internal surface of the bone. And so this slide should give you a good sense of both bone development from a hyaline cartilage model and the overall structure of a long bone as we see it during development, in which we have progressive conversion of the cartilage model, which was initially laid down, into bony material itself.